Hey, in this video, we're going to have a look at the language around polynomials. Okay, so polynomial function can be written in the form p of x equals a n x to the n plus a n take 1 x to the n take 1, and so on, all the way up to a to the 1 x plus a 0. Now, what's all this actually mean? Okay, basically we're saying we've got a whole heap of terms one after each other. Okay. Where our indices or our powers are listed in descending order. So our largest one is going to be first. Okay, and what we say is n is a natural number. Okay, and the coefficients a n all the way up to a0 are real numbers. Okay, we just can't have a n equaling 0. The first one can't equal 0. Okay, we don't have to include all of our possible indices in our list. So if this, for example, was a to the power of 4, x to the power of 4, we don't have to have an x cubed, an x squared, and an x term. Okay, we may skip some, and that's because some of these coefficients could be 0. Okay, if we think about poly means many. Okay, so polynomial function is a function with lots of parts. Okay, and in this case, they're all just to the power of some number. Okay, so a little bit more information. The leading term, a n x to the n, has the highest index. That's what we're saying. This has the biggest power. Okay, the degree of a polynomial is the index of that first term. Okay, so if we have a cubic, okay, x to the power 3, where we say that's a polynomial of degree 3. Okay, if it was x to the power 5, okay, it would have a degree of 5. Okay, a monic polynomial is where the leading coefficient is 1. Okay, so that's saying that this a n value is 1. Okay, so if we have, say, x squared plus 3x plus 4, okay, that's going to be monic because the x squared term is just x squared. It's not 4x squared, for example. Okay, a constant term has no variable and is given last. Okay, that's this a naught value over here. Okay, that's just a number. Okay, and that's our constant term. Okay, it's always at the end. Okay, so we'll move on. We've got a bit more to have a look at. We're looking at some arithmetic with polynomials now. Okay, so basically we're just saying what happens if we are trying to add them, subtract them, or multiply them. Okay, so what we do, okay, is it's easiest to explain with an example. So if p of x equals x cubed plus 3x squared plus 2, and q of x equals 2x squared plus 4, then adding them together is simply, we write each one out, notice the brackets though, okay, and then we just simply add like terms. So that this is only x to the power 3x cubed term, so it's by itself, but then we have 3x squared plus 2x squared gives us 5x squared, 2 plus 4 gives us 6. So we're going to simply add our like terms together. Okay. Similarly, when we've got p of x take q of x, now the brackets here are super important, okay, because we're taking away every term that's in this set of brackets. So, so that should be 3. We have x cubed. Okay, we don't have any to take away, so we've still got it all. Then we've got 3x squared take 2x squared is going to leave us with x squared. And then we have 2 take 4. Okay, so we're not adding the 4 on, even though it's plus here. Okay, and this is why we have our brackets. If we didn't write it, we would just written it like this. If we didn't have those brackets, and we would have said, oh yeah, I take my 2x squared away and then I add my 4. Okay, that'd be incorrect. We've got to take away every term that we've got here. So it's 2 take 4 gives us negative 2. Okay, similarly, if we were to multiply these, okay, then we have our 2 sets of brackets and we've got to expand them out. So that means that every term in this bracket gets multiplied by every term in this bracket. Okay, so we've gone 2x squared by x cubed gives us 2x5. Okay, 2x squared times 3x squared gives us 6x to the 4. Okay, 2x squared times 2 gives us 4x squared. Then we go 4 times x cubed gives us 4x cubed. 4 times 3x squared gives us 12x squared. And 4 times 2 is 8. Okay, then we can simply collect our like terms. Okay, this is only power 5, this is only power 4, this is only power 3, but we have these 2 terms here with x to the power 2. Okay, so that gives us our 16x squared plus our 8 at the end. Okay, now you may be thinking, well, what happens if I have p of x divided by q of x? Okay, and we actually look at that specific example in quite a fair bit of detail in later sections. Okay, so we won't worry about that case. Okay, so we're almost there. Okay, got a couple little bit more points to cover. Okay? And that's about equating coefficients. Okay, so if we've got these two polynomials, p of x equals 4x cubed plus 5x squared, take x plus 3, and q of x equals ax cubed plus bx squared plus cx plus d. Okay? Well, the only way these two things are equal is if and only if, okay, a, the coefficient of x cubed, okay, has to equal 4. Okay, and b, the coefficient of x squared, has to equal 5, c has to equal -1, and d has to equal 3. Okay, so all of those things have to be equal for those to be equal. Okay, and that's why we've got this technical language of if and only if all these things happen. Okay, just a little bit there. Okay, it's not going to come up too often, but it's just something to be mindful of, and it's pretty. It makes sense. Okay, two things can't be equal if they don't look the same. Right. And the other thing that we have a look at, and this is one that you can delve so far into it's not funny, okay, but expanding. Okay, so if we have a plus b to the power of n, okay, well if we expand that, we get a squared plus 2ab plus b squared. That's not that uncommon. Okay, this is a quadratic. We've seen this type of thing before. If we look at a cubic, we've got a plus b cubed, then expand it out, we get a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, and a plus b to the 4 gives us a to the 4 plus 4a cubed b plus 6a squared b squared plus 4ab squared plus b to the 4. Okay, and you can keep going on and on and on with these if you wanted to, and keep going higher. Now, what we say is each of these is an identity. Okay, so if you are asked to expand something that's in this form, you can straight away do it like this. Okay, just simply note it here, okay, for your reference, the coefficients of each of these terms. So 1, 2, then 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, and we can see there that there's clearly a bit of a pattern happening. Okay, and we can actually come up higher here. If we were expanding a plus b to the 1, we'd just get a plus b. And if we were expanding a plus b to 0, well, anything to the power of 0 is equal to 1. Okay, and we end up with this nice pyramid, this nice triangle, right? And that's known as Pascal's triangle. Now, I could do a whole other video that would be quite extensive just talking about Pascal's triangle. It's actually a really nifty thing. There's lots of patterns that come up everywhere. Okay, if you're interested, Google Pascal's triangle or YouTube it. There'll be lots of videos out there already. Okay, so look, hopefully that's just enough, a little bit of an introduction on polynomials, okay, and will help you with the questions that you need to answer.